Tutorial, I will explain to you how can you know if a process is spontaneous or non-spontaneous by looking at the sign of delta G. So first of all, delta G is what we call the Gibbs free energy. And it means that this is the energy available for a system in order for the system to do the work, like to start the process. So there are two basic things. If the delta G value was negative, it means that the system is spontaneous. There is energy available to do the work. What is the work? It's the reaction itself. Now, if delta G is positive, it means that the process is non-spontaneous. There is no energy available to do the work. That's why we need to input energy, non-spontaneous. Like, let's say, if I have delta G is equal to negative 500 kilojoules, it means that there are 500 kilojoules of energy available to do the reaction, to do the work. Now, if I have delta G is equal to negative 100 kilojoule, it means that there is 100 energy available to do the work. Now, both of them are spontaneous, but this is more spontaneous than this one. Now, again, if I tell you I have a delta G of 500 positive kilojoule, it means we need at least 500 kilojoules of energy for this system to start happening and taking place. So it is non-spontaneous. Just like if you look at the battery of your mobile, if the battery is full, I'm just gonna draw it over here. So let's say you look at your smartphone, and the battery is showing a level up till here. It means there is energy for this mobile to keep on working. So it's gonna work. Now, if the battery was like that, it means there is more energy available in my mobile to continue working. Now, if the battery is empty, there is no energy and the mobile will simply switch off. There is no energy. We need to supply it with energy so that the mobile can turn on and work. So it is as simple as that. And I've written a summary for it over here that you can look at it. Now, let's move on. About the units of delta G, delta H, and T, delta S. Because whenever we are doing calculations and solving questions in order to determine if delta G is spontaneous or not, we need to use the correct units. So, delta H and delta G will always have the same units. Same unit, and they are in kilojoule per mole. Now, the temperature is always in Kelvin. Now, if in the question they gave you T in Celsius, this means that you need to convert it to Kelvin. So if temperature is given in Celsius, you must convert it. Now, how do you convert it? Simply, you add 273. So if a question is telling me that the reaction is happening at 25 Celsius, you cannot just substitute 25 over here. You must change it to Kelvin, and then you substitute over here. That's for T. Now, delta H and T. Now we need to talk about delta S. Delta S, when we studied entropy of the reaction, entropy change, we said that the entropy is given in joules per mole Kelvin. Now, when we plug the data into this formula, we cannot use a kilojoule and then a joule. This means that delta S, always you must convert it to kilojoule per mole Kelvin. So Delta S, the entropy is in joule, is always given in joule per mole Kelvin, and it should always be converted, must convert it to kilojoule per mole Kelvin. Now, how do you do this? You simply divide by 1000. So if I give you, for example, 60 joule per mole Kelvin, you cannot just write 60 over here immediately. You must divide it by 1000 in order to get the answer in kilojoule per mole Kelvin. Okay? So, let's summarize this up. This must be in kilojoule per mole, delta H kilojoule per mole, T must be in Kelvin. So if it's not in Kelvin, you simply add 273 to become in Kelvin. And this one must be, you must change it to kilojoule per mole Kelvin, and it's usually given in joule mole Kelvin. So you divide it by 1000 to get it in kilojoule per mole Kelvin. That's the way we solve these questions. So now also one more thing. If the question is not dealing with a standard Gibbs free energy and enthalpy and entropy, in this case, it would be simply kilojoule, no more per mole in the unit. This is just a quick information. Now, let's do this question. Calculate the free energy delta G standard for this reaction at 250 Celsius. I said that the temperature must be in Kelvin. So, for this 250, I need to convert it. So temperature, you say 250 plus 273, and that is 523 Kelvin. Now temperature is ready. Is the reaction spontaneous or not? It depends on the value of delta G. Now let's look at delta H. The given unit of delta H is correct. So I'm gonna use it, no changes to delta H. However, when I look at the entropy, it is given to me in joule per mole Kelvin. It means I must divide it by 1000. So the delta S is 60 divided by 1000, which is 0.06 kilojoule per mole Kelvin. And now I'm ready to start plugging this into my formula. Delta G is equal to delta H negative 4.8 minus, now I have the temperature 523 and I have the entropy after converting it 0.06. So the answer is going to be negative 36. Guess, let me double check. So it is negative 36.18 and the unit is kilojoule per mole. Now, is this reaction spontaneous or not? It is spontaneous. Why? Because delta G is negative. Let's look at another question. So, here we go. I have here not standard. I just have delta H and delta S and delta T, not, delta H and delta S not per mole because they're not just in the standard form. So we're just gonna move with the formula, go with the formula. So here's the delta H and here's the delta S and it's in joules. So I must convert it to kilojoule by dividing to 1000. Here's the temperature. It's in Celsius. I must convert it to Kelvin. So delta S is equal to 142.2 divided by 1000. That is equal to 0.1422 kilojoule per Kelvin. Now the temperature, it is in Celsius, and we need to convert it to Kelvin. So we add to it 273, and the answer would be 298 Kelvin. Now we start substituting in the formula of delta G equal delta H minus T delta S. So delta H is 95.7 minus the temperature, we just converted it to Kelvin, and the entropy, we changed it to kilojoule per Kelvin. Working this on our calculator, we find the answer to be 53.3 kilojoule. Therefore, the value of delta G is positive. The value of delta G is positive. Therefore, it is non-spontaneous. Part 2 of our video tutorial, I'm going to explain to you how do you determine if the process is spontaneous or not by simply looking at the signs of enthalpy and entropy changes. So, this is something just you have to work out the signs. Let me just clarify it in this way. We always look at the signs of enthalpy and entropy change. Now, just keep it that way. Usually, an exothermic process with an increasing entropy is always spontaneous, while an endothermic process with a decreasing entropy is never spontaneous. So this is how I explain it. If delta H and delta S have opposite signs, let's look at it. This is negative and this is positive, or this is positive and this is negative. So let's look at the negative one. This is exothermic process with an increasing entropy. At this point, the system is always spontaneous, no matter what. Always spontaneous. Now, if the enthalpy is positive, it means that the system is endothermic with a decreasing entropy. The system is never spontaneous. So always look at the signs of delta H and delta S. And the first thing, ask yourself, do they have opposite signs or do they have same signs? Now, let's look at what happens if delta H and delta S, they have the same sign. It means, so if both of them are positive or both of them are negative. What does it mean if both of them are positive? It means that I have an endothermic system with an increasing entropy. At this point, the reaction is spontaneous, but only at high temperatures. Only at high temperatures. It means that the temperature must be above a certain value to become spontaneous. So how is that? You just look at T and you say that temperature must be above delta H over delta S. So you just calculate the value of delta H over delta S, and you should say that the temperature must be higher than this value. So for the reaction to start being spontaneous. And if the reaction, I'm just going to change this a bit. It looks weird the way I wrote it. So spontaneous only at high temperature. And if I have the system exothermic, it means, and the entropy is decreasing, there's a condition. This one would be spontaneous only at low temperatures. It means that the temperature must be less than delta H over delta S. Now I've summarized this also in another table over here. So negative and positive delta H, and these are the conditions. Spontaneous at high temperature when both of them are positive, spontaneous at low temperature when both of them are negative. If it is exothermic with an increasing entropy, it's forever spontaneous. And for an endothermic process with decreasing entropy, it's never spontaneous. So let's look at this one. Here, the first thing you look at, search for delta H and delta S having opposite signs. These two, they have opposite signs. So the exothermic one is forever spontaneous. So this one, this process or process L is always spontaneous no matter what was the temperature. And process K is endothermic because it's positive, and this one is decreasing. It's never spontaneous. Now, when both of them are negative, it is spontaneous at low temperature. When both of them are spontaneous or positive, it is spontaneous only at high temperatures. Let's look at more questions. Here are some examples. The question is giving me already the enthalpy, the delta H. So let me just put a table and examine delta H and delta S. Gas to liquid, energy is released. It's an exothermic process. And also it's saying here negative enthalpy. However, for the entropy of a system to move from gas to liquid, entropy decreases, so entropy is negative. Now, when both of them, they have same signs, negative, negative, it means that this system is spontaneous at low temperature. So here, spontaneous or not. Now let's look at the other example. This one, they are informing me that this reaction is endothermic, having enthalpy positive. Now let's look at entropy. I have a system that was in gas turned to liquid. Entropy decreased. Also, I had 3 moles reacting. Now I obtained in the product 1 mole. So again, entropy is decreasing. It's negative. So for an endothermic process, when delta H and delta S have opposite signs, it is never spontaneous for the case of endothermic system. So this one is never spontaneous. Now, one more example. This is a combustion reaction, so the enthalpy is always negative. It's exothermic. Now let's look at this one. I have 3 moles changing into 3 moles. However, since this is a combustion reaction when burning, it will have a it will have a positive increasing entropy. And in this case, this reaction, since delta H and delta S have opposite signs and this is exothermic, so this reaction is always spontaneous. Let's look at more examples. I have the sign of delta H over here, and I'm gonna write a table for delta S, and then I'll look at delta G to see if the process is spontaneous or not. Now, delta H is negative, exothermic. Now, let's look at delta S. I have 9 molecules turning into 10. So the entropy is increasing. An exothermic system with an increasing entropy, the reaction is forever spontaneous. It's always spontaneous. Now let's look at this example. Again, it's exothermic. However, I have 3 moles turning into 2. It means that the entropy is decreasing. So this process is spontaneous. They have same signs. Spontaneous only at low temperatures. Now let's look at this one. The enthalpy is positive, endothermic, but the entropy, I have 6 solid, and now I have gas and solid. Okay, so if I have gas and solid, it means that the entropy is increasing because of the entropy of the gas. It's much higher. So here, entropy is increasing, positive and positive. This one is spontaneous. When they have both same signs, it is spontaneous only when temperature is high.